Hello, my dear students. Welcome to the electronics session 16. Okay, so this is the class for the session 16 BSc first year electronics, University of Mysore. Okay, let us begin the today's session. In this session, you are going to study the construction, formation of depletion layer, IV characteristics of junction diode. Okay, before going to start the today's session, let us revise what we studied in the last class. What is PN junction diode, practical and ideal diode, its symbol, and what do you mean by the biasing. Okay, let us begin the today's class. Okay, myself Lata Kulkarni, Department of Electronics, Assistant Professor, Maharani Science College, Mysore. Okay, what is the objectives of the today's session? Today's session begins with the construction of the PN junction diode, formation of the depletion layer, and the IV characteristics. Okay, after studying this video, you should know how to construct the PN junction diode and how the depletion layer is formed in the PN junction, and what are the IV characteristics of the PN junction diode and the ideal diode. Okay, let us begin the session with the construction. Okay, so as we know that the PN junction diode contains the P and N type material. How they are going to construct means they are taking any one material of the silicon or the germanium. That means actually PN junction diodes are constructed using the silicon or the germanium material, semiconductor material. Okay, let us, and they are taking any one of the germanium or the silicon material. Half of that material is doped with the P type material, P type impurity, and another half is N type of impurity, as shown here in the figure. I shown the construction. Okay, here full any one piece of the material is taken. Here two pieces taking and the sandwiching is not possible. What we have to do means we have to take it one whole piece of the any silicon or the germanium. Okay, in that what happens, half of the that material is doped with the P type impurity, and that P type is called the anode, and another half type is doped with the N type impurity, that is called the cathode. That means one terminal is taken from the P material, another terminal is taken from the N material. The material taken by the P side is called the anode. The materials taken by the N type is called the cathode. Okay, this is shown. This is nothing but what here the symbol actually I have written. Actually, I want to show you that it has the two terminal device, and this triangle what it indicates means it is flow of the current in the forward bias. Okay, this is about what your construction of the PN junction diode. Next, let us move to the second point of our this session is formation of the depletion layer. Okay, so till now we studied the construction. In the constructions, just we have studied what is that. That diode contains the P type material and the N type material. Okay, and here what happens when P and N type is combined, here we are going to get a one layer. This is called the PN junction. Okay, remember that this is called the PN junction. So here if you want, you go here and read. The diode is formed by joining both N type and the P type semiconductor together. This device is a combination of P type and N type semiconductor material, hence it is known as PN junction diode. Okay, a junction is formed between the P type and the N type material, and this junction is known as the PN junction. Okay, now let us our point is how this is going to form the depletion layer. Okay, correct. So this is all of we know that this is P type material. P type material has the majority carriers are the holes. Okay, that is represented as plus in our figure. And the n-type material is nothing but that when the majority carriers are the electrons. And next, in the p-type material, what are the minority carriers? Electrons are the minority carriers. And in the n-type material, what happens? The minority carriers are the holes. Here what happens? Because of this difference, that is minority and the majority carriers, okay, it uses the concept of this and produces the depletion layer. Here what happens, all the holes are attracted towards the electrons and the electrons are attracted towards the holes. Okay, so here some of the holes that are crosses this junction and combines with the n type. And here in the n type what happens? The electrons, they are attracted towards the holes. Okay. So after combining this, what happens? They form a one layer at the junction. Okay, this combined electrons and holes are there, no? They form a one junction. They form a one layer near the junction. This is called the depletion layer. Okay, so how we are going to perform the depletion layer means, actually holes diffuses from p to n region and electrons from n to p region, as shown here. As I shown in this one, holes are diffuses from p to n region and electrons are diffuses from n to p region. The recombination of the free and mobile holes of electrons produces a narrow region at the junction called the depletion layer. Okay, it is so called because this is a depleted for the free and mobile charge carriers, through it does not contain fixed or immobile positive and negative ions. Okay, this is called the depletion layer. Okay, let us revise simply. Simple step to understand this means, I revise in one or two sentence how the depletion layer is formed in the p-n junction. Okay, p type contains the majority are the holes, n type are the majority are the electrons, minorities in the p type are the electrons, minorities in the n type are the holes. Okay, so as we know that holes are attracted towards the electrons, electrons are attracted towards the holes. Here some of the electrons are moving towards the p type and some of the holes, they are moving towards the electrons. They form a, and they are immobile ions when they are combining with these electrons. When combined with these holes, after these holes, they are afterwards immobile ions. They form a one layer near the junction. Okay, here you see, here this is the, it forms the, in the n region it forms the holes, and in the p we are going to see the, actually there these electrons recombine with holes and these holes recombine with electrons. They form a one layer at the p-n junction. This is called the depletion layer. Okay, let us hope all of you understood how the p-n junction depletion layer forms. Okay, let us move to the IV characteristics. Okay, so when we have to study the IV characteristics means, we should know that it is having the two types of the IV characteristics. That is, one is called the forward bias IV characteristics, another is called the reverse bias. This what you are seeing, this figure, this is the forward bias IV characteristics. Okay, the characteristics drawn between the x and the y axis. In the x axis we are taking the volts, and in the y axis we are taking the current. Okay, when you draw the graph, then it is called IV characteristics of the PN junction diode. And all of you know what is forward biased. When the diode is connected to the, when the positive of the diode is connected to the positive of the battery, negative is connected to the n type, then it is called the forward biased. Okay, if you are increasing the voltage from 0.1 0.2 like that, so when the diode is forward biased, what happens? So before going to start this analysis, I want to tell you that here we have shown the characteristics for both germanium and the silicon. Okay, just now we studied that in the construction, if you are using the germanium semiconductor, then that diode is called the germanium, and if you are using the silicon, that is silicon diode. Okay, so I showed the both the characteristics, germanium and the silicon. So just first you think that I have used the germanium. Here what happens, when you increase the voltage from 0.1 0.2 0.3 till 0.3, we are getting very small current, that to 1 milliampere. Okay, here you are seeing in the graph, if we increase the voltage from 0.1 to 0.3, we are getting a only small current, that too in milliampere. But when you start increasing from 0.3 to 0.4, that too within a just 0.1 volts, there is a rise in the current. Okay, there is a rise in the current for the germanium voltage. That means what? Means diode is starts conducting from the 0.3 volts. Okay, diode starts conducting from the 0.3 volts for the germanium. In the same way, just if you are observing for the silicon here, what happens for the silicon, till 0.7 there is only 1 milliampere is the current, but when it reaches 0.7, then there is a sudden increase in the current. So when in the forward bias, what happens for the germanium? For the germanium, what happens after the 0.3, we are able to get the more current, whereas in the silicon after the 0.7 we are going to get the more current. Okay, so when it starts conducting, no, this 0.7 for the germanium and 0.3 for the 0.3 for the germanium and 0.7 for the silicon, this voltage is called the knee voltage. Okay, this voltage is called the knee voltage. Okay, okay, let us hope all of you understood this one. Next, now move to the reverse bias characteristics. What do you mean by the reverse bias? So here in the reverse bias, all of we know that when the diode is forward biased, it starts conducting. That means current is flowing from positive end to the negative end. Whereas in the reverse, when the diode is in reverse bias, it does not conduct. That means you are not able to get any current. Okay, but even though we are going to get the some current, so here you see where you are going to draw the reverse characteristics. This is the negative term, negative of the graph we are going to draw. Here you see -1, -2, -3, and here this is the negative region of the graph we are going to write here minus. So if your reverse bias means the current is in reverse, that is -1, -2. So here this is the 0 point. From 0 to -1 there is a small increase in the current, that too only -1. And what is the unit means it is microamps. Micro means it is a very small current. Okay, why you are getting this very small current? This is you are getting due to the minority carriers. Okay, afterwards it remains constant. There is no change in the current. We are not able to get more current in the reverse characteristics. Okay, and the final object is ideal diode and its characteristics. Okay, so the ideal means what? When the diode is forward biased, then what happens? It is acts as a conductor. That means full, there is no loss in the current. Okay, and when it is in reverse biased, it is full insulator, no conduction is there. In the forward bias there is no losses, in the reverse bias there is no conduction. Okay, it perfectly acts as an insulator. In the graph you are saying here, if I draw the graph, this is the voltage and this is the current. Actually here it is 0 is there. When it is 0, for the 0 voltage only we are getting the maximum current in the forward biased. Whereas in the reverse biased we are getting 0 current and the 0 when the voltage is increasing but there is no current. You are increasing the voltage but there is no current here, because in the reverse bias the diode acts as an insulator. There is no flow of current. Just in the PN junction diode, that is in the practical diode, you are getting some current, whereas in the ideal diode we are not able to get any current. But practically it is one impossible task. That is not possible. Okay, so so here dear students, here some MCQs are given. Just to go through this MCQ. Okay, just these are the some references is also given. If I want to revise the today's class, means what we studied in the today's class, how to construct the PN junction diode, and how the depletion layer is formed, and we studied the characteristics of the PN junction diode and the ideal diode. Okay, please go through the video once again and solve the MCQs. Okay, thank you students.